This video is for the knowledge organizer on error intervals. What I would like you to do is read your knowledge organizer, watch this video and work through the examples from page 1, try the questions from the second page of the knowledge organizer and complete any maths watch work set. Okay, what we're going to do is we're looking at error intervals. When a number has been rounded to a given unit, the actual number could be up to half a unit bigger or smaller than the rounded number. Now I'm going to come back to that in a minute. What we're going to do is we're going to say when m equals 20 and it's rounded to one significant figure, find the interval within the actual value that m lies. Now that sounds quite confusing. When we talk about error intervals, they are set out using an inequality. So an error interval basically is going to be an inequality and you have to find the numbers either side of it. That inequality is going to say that m is equal to that number or bigger and less than that number. Now notice there isn't a line underneath that. That's really important for what we're going to do. Now going back up here, it says when a number has been rounded to a given unit, the actual number could be up to half a unit bigger or smaller than the rounded number. So if we have a look at this is number here. It's been rounded to one significant figure. The first significant figure is in the tens column. So it's been rounded to the nearest 10. So what we want to do is we want to say, right, what numbers when are rounded to the nearest 10 give me 20? Well, let's think about this. 17 when it's rounded to the nearest 10 goes to 20. 16 when it's rounded to the nearest 10 goes to 20. What's the smallest number we can have? Could we have 14? 14 when it's rounded to the nearest 10 gives me 10. So the smallest number we can have would be 15. Okay? If you think either side of that, if you had 14.9, that would give you 10. So we can have decimal values. So the smallest number is going to be 15. Okay? So that's that value there. Okay? The smallest value we can have when our number is rounded to the nearest 10 would be 15. Now, we want to think about our biggest number. Okay? So think about what's the biggest number you can think of. Well, 24, when it's rounded to the nearest 10, gives me 20. It's the biggest whole number. Is there a number bigger than that, though, that rounds to the nearest 10 and gives me 20? Well, actually, yes, there is. 24.9 rounds to the nearest 10, and it gives me 20. In fact, I can think of an even bigger number, 24.99, and that gives me 20. And an even bigger number, 24.999, that gives me 20. And even bigger, 24.999999999, that gives me 20. So 24.9 recurring, when it's rounded to the nearest 10, gives me 20. Now, notice I said I was going to come back to this and why it didn't have an equal sign on. It doesn't have an equal sign on because when you get your numbers so big that it's 24.9 recurring, we're going to just say that that number there is 25, but it can't be equal to 25. So we're going to say that because we don't want to write 24.9 recurring there, we're going to say that that is 25, and that's why we don't have an equal sign on, because that number is less than 25. It's 24.9 recurring. It's 24.9999. That goes on forever. So when we're writing our error interval, we use our inequalities that look like this, and we write down the smallest number it can be and the biggest number it can be, but we bear in mind that the biggest number it can be is going to be less than that whole number. Now, what you should do is you should notice a pattern here. You should notice that we were originally looking for numbers that round to give 20 to the nearest 10. And that is 5 away from our value of 20, and that is 5 away from our value of 20. So there is a bit of a trick here. What we could have done is said that that is rounded to the nearest 10. If we half that, it gives us 5. And all we have to do for this value here is do 20 take away 5 and 20 add 5. Now I'm going to go through two more examples that you've got on your sheet of paper to help you get started with this, because it's really hard. So it says your knowledge organizer says write an error interval, and it's asking you to round these numbers. Okay, so I'm going to just write an error interval. I'm going to start it off and I'm going to use M. You could use X, that letter in the middle doesn't matter, but I'm going to have it written like that. And it says I've got 4 grams measured to the nearest gram. Well, the nearest gram just means to the nearest whole number. So what I think of is I say that's measured to the nearest gram, so that's measured to the nearest one. What I do is I half that, and that gives me 0.5. That means I'm going to do 4 take away 0.5 and 4 plus 0.5. So therefore, my smallest value is 3.5 and my largest value is 4.5. And there we go, we've wrote our error interval. Okay. For this question here, we're going to measure it to the nearest 10 kilograms. So that means measure to the nearest 10. So we half it. That gives us 5. Now, we're going to have our interval, and we're going to have our 2 values that we have to put in here. It's 50, so we're going to do 50 take away 5 here, and we're going to do 50 plus 5 here. And that means that we have 45 as our smallest value. That can be rounded to the nearest 10 and gives us 50. And we'd have 55 here, remembering that it means it's less than 55. What I would like you to do, use your knowledge organizer and this video to complete the questions on page 2, and then complete any Maths Watch work set by your class teacher. Thank you.